everyone, I'm Nick from Coffee Before Arch, and in this episode of C++ Crash Course, we're going to be talking about iterators. Now, last time when we talked about sequential containers, we saw that there was this iterator thing that we used for a number of times, right? So we used it from algorithm when we were sorting an array in place. We saw that for something like a list, right? We'd set an iterator to find a spot inside of that list. So in this case, we set the iterator to intlist.begin or intlist.end in other cases. And we saw this, r_begin and r_end, but we didn't really explain what the purpose of iterators is. So let's go ahead and look at an example where we go over this in more detail. So under fundamental concepts, miscellaneous, and under iterators. We'll look at iterators.cp, and we'll reduce this to just talking about vectors for now. But the key strength about iterators is that they're very generic, right? So that they can be used with strings, they can be used with a forward list, or just a list, or something like a dequeue, right? So a doubly inded queue, right? So so here we'll just create a simple vector of integers. So we'll just call this int_vec, and we'll push back 10 elements. So while we can index like normal, like a C-style array, where we just use the brackets and then a number, say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'd like a more generic way to refer to different spots, or a more generic way that encompasses more different types of containers, right? And for that we can use iterators, right? Iterators are really useful for this. Now, in this case, right, so this all comes from the particular data structure you're using. So you can, in this case, we'll get a vector int iterator. So we use this scope resolution operator. For the vector class, we need to specify a type of vector that it is. So in this case, an int, and then we get an iterator, and we'll call this iterator begin or iterator end, right? And so we can set this to int_vec.begin and int_vec.end. And what these return is an iterator to the beginning of a vector or the end, right? So if we have a vector over here, let's represent it kind of like an array. So we'll have 0, 1, 2, ... all the way up to 9. Right, so int_vec.begin will point to this first element. Now, int_vec.end actually points to one past the last element, right? So end is actually just off the end, right? And so this is very similar to how we normally do for loops, right? So we would, a classical way that we've looked at for loops in the past for something like a vector is we check the vector size, right? So the size is 10 elements, but the index is only 0 through 9. So we'll say, while I say is less than the size, or 10, right? So in this case, end just points to one past the last element. Now, when we're doing a for loop, right, using an iterator, a lot of times we won't specify, say, vector int iterator, iterator begin. We use auto types a lot when we're working with iterators. So say in a for loop, right, just like we do int I is equal to 0. In this case, we do auto I is equal to int_vec.begin. So when we're working with things that aren't necessarily indexed by a specific number, say we're working with a hash table, and it's indexed by something else. Maybe it's indexed by say a string, right? Int_vec.begin, right? So we wouldn't say int I is equal to 0 to iterate over a hash table, right? But we can use iterators to do the same thing. So we'll say I is equal to int_vec.begin. I is not equal to int_vec.end. So this is very similar to doing I is less than vector dot size, and then I++. So when we use this increment operator, this will just move kind of like a pointer. It'll just move it to the next element in that container, right? And so the key thing about this is we're keeping things very generic, right? So it's not tied to vectors, right? So all these containers have the same kind of construct. And so if we actually want to access the value at that iterator's location, right, we can just dereference it like we would a pointer, right? So we do the star, and in this case I. So I will be the iterator at the specific location. So in this case, it'll be all of the elements that we have. Now, another nice thing about iterators is that we can do it in reverse, right? In a lot of cases, right? So a lot of these containers also support reverse iterators. So we can use intvec.rbegin, and then while I is not equal to intvec.rend, right? So, because we're not just using a, kind of raw C array, we don't need to worry about, going backwards and just using, say, an integer as an index, right? We can just, we can get rbegin and rend, and this will iterate over this vector in reverse order now. So instead of printing out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it'll print out 9, 8, 7, 6, 5, 4, 3, 2, 1. Right, so these elements are connected to each other, right, and we can use rbegin and rend as a simple way of accessing things in reverse. But again, the key point here is that with these iterators, we're keeping things generic, right? So this extends to multiple different types of containers, right? So let's see what happens here. So let's go ahead and compile this. So G++, set the standard equal to C++11. And then we'll go ahead and put iterators, and our output we'll just call iterators as well, right? And then let's go ahead and run this. And so, very unsurprisingly, so when we go from setting the iterator equal to intvec.begin, we get all the way to 1 less than intvec.end, or while it's not equal to intvec.end, we get 0 through 9 in order. And then when we do rbegin and rend, so basically a reverse iterator, we get it backwards, right? So this is a convenient way, and just like we looked with sequential containers, so we can go back to that example really quick. So let's go back to the standard library and then sequential containers, and we'll open up this example. So you see that there's a lot of things that we can do with iterators, right? So over here, if we want to use the algorithm from the standard library, so we can do sort, and we pass it to iterators, so begin and end, or we can pass it to arbitrary locations inside of that container. Likewise, we use that when we're doing something like when we're working with something like a list, where do we want to insert, right? So we can just pass it an iterator in what value we want to insert at that point. And again, for something say like a dequeue, right? So over here, over here, we're still using iterators, right? So we're using print container, and print container, right? So for this, we're using another C++ feature, these kind of for each loops. But just as easily, we could be using iterators as well. But that's going to do it for this example. So this is really one of the key parts of C++. So when we're writing in C++, it's important that we follow a lot of the C++ programming guides, and so we use things like iterators and things that are available to us instead of more raw C style features. But that's it for today. Feel free to check out any of this code at github.com/coffeebeforearch. So we looked at C++ crash course, but we've got other series here on data structures, CUDA programming, so that's GPU programming, etc. So again, C++ crash course. And we looked at from fundamental concepts, we looked at, let's see, it's in miscellaneous topics and iterators. So feel free to download this, play around with it, and let me know if you have any questions. And as always, I'm Nick from Coffee Before Arch, and I hope you have a nice day.